Well, good evening. I hope everybody's safe and well. It feels like a long time since we've had one of our Monday night Q&A sessions. So I hope you're all well and going to enjoy it and participate as much as in the past. I'm joined tonight by my colleague from the technical helpline, Mark Barnes-Ryder. Good evening, Mark.
Hi, Sam.
How are you this evening?
Yeah, very well. Not bad, thank you. Not bad.
It does. It feels like a long time since we've done one of these. I know we've been posting questions out through social media channels, but we've not actually done a live Q&A session for a month now, I think, which is it does seem an awfully long time.
It does. Yeah, I can't remember the last time that I did one actually, Sam. But without looking at my calendar, but yes, yeah, it's the time flies by, doesn't it?
It does. I think definitely the older we get, unfortunately, the quicker it goes. So yeah, really interesting. Right, we'll make no further ado. So we'll have a look at this week's question, which we posted out through our channels earlier today. So the question today was: are domestic kitchen appliances required to have an isolator for compliance with 7671? The requirements for electrical installations? And it was a very simple poll, yes or no. So are domestic kitchen appliances required to have an isolator for compliance with 7671? So what's our first thoughts on that, Mark?
I think my first thought is to take everybody back to sort of fundamental principles, because that tends to sort of, you know, part one is fundamental principles, and we often sort of forget about them. We dive straight into, you know, parts 4, parts 5. So, you know, if we take them back to 132.15.201, that's it says that you know, effective means suitably placed for ready operation shall be provided, so that all voltage may be cut off from every installation, from every circuit, and from all equipment. So that's where the items for individual equipment come into play. But you know, BS 7671 doesn't state specifically that you've got to have one for each piece of equipment. Sort of, you know, you're going to have it locally. Although, you know, if there's increased sort of maintenance required, or for other reasons, you may well want one that's more local than having to go back to the fuse board to switch the whole circuit off, for example. So and also you've got to take into account manufacturer's instructions as well. If you are going to put isolators remotely, then they'll either have to be obvious by their position to indicate the circuit or the equipment they're protecting, isolating, or they need to be suitably labelled. So, you know, equipment, if you look at the definition, it says equipment such as items that are used for purposes of generation, conversion, distribution or utilisation of electrical energy. So that can be anything from machines, transformers, accessories and appliances, for example. So
yeah, it's key, isn't it, that definition of electrical equipment includes specifically appliances. So that kind of nails it, that it does include our appliances. And it's so true. I mean, we were talking earlier today about how, you know, we were always taught that you use 7671 in terms of design from front to back as you go through the process. So what's it all about was how it was described to me. That's part one, which includes your fundamental principles. So this is what we aim to achieve, and then the rest of the book tells us detail of how and why in often reasons. So yeah, those fundamental principles often forgotten about, and people tend to dive into parts 4 and parts 5 when they're trying to reason why they're going to do something. Quite often the answer's actually in part 1. So that's really good. And yeah, like you say, it says it clearly. it's quite interesting. We had a lot of chatter on social media saying that, well, you have to do every circuit, don't you? So every appliance, but the fundamental principle reg is quite simple and quite plain, and it says yes, every item of equipment, every circuit, and every installation. It doesn't go as far as to have to say they have to be independent means of isolation, but every installation, every circuit, and every item of equipment has to be provided with a means of isolation. What about local? Yeah, a lot of people ask, what are the kind of things that determine whether it needs to be local, Mark?
I mean, manufacturer's instructions for one thing. Excuse me. They may dictate that they should be within 2 meters of an appliance or something like that. But a risk assessment as well, is to determine how frequent, some of this equipment's going to be moved or dislodged for maintenance, for example. So it's a risk assessment. We say that word a lot, that needs to be carried out, but talk to the client as well. The client will also specify, often with built-in appliances, and we all know these days they don't all want the isolators perhaps dotted across the wall, and it might be feasible to put them all in one place, but often as it is a risk assessment of the potential hazards. If you're for example, cookers that generate heat, or you might have accessory equipment that's got moving parts that could pose a risk to ordinary persons using that installation. So they're the kind of things you need to think about in your risk assessment and such like. Yeah.
So it's again the reg in fundamental principles talks about suitably placed as may be necessary to prevent or remove danger. So it would be associated with the particular hazards, the likelihood or risk of those hazards actually occurring. I think the two examples that industry tend to use are things that generate heat, so obviously you've got a risk of fire, and things that have got external moving parts, so you've got the possibility of entanglement or entrapment to users of the installation, depending upon whether those things are accessible. So it is a risk-based decision whether it has to be local, and also, as you rightly said, consideration as always of manufacturer's instructions, which might talk about a requirement.
I mean, the hazard, just very quickly, the hazards may well be more obvious in a commercial and an industrial environment, so perhaps not so obvious, and perhaps not so frequent in a domestic environment. But it's BS 7671 doesn't distinguish between commercial, industrial, or domestic for that matter. So the risk assessment needs to be relevant to the installation, doesn't it?
Yeah. We've got some other questions, but we'll just answer because there's one that's come into the chat room which is associated with this, and the question is valid, and it's one that we've come across more and more frequently. So what if you had an island? So I guess we're talking about a kitchen island rather than Richard Branson type island. So what if you had an island with no easy access or visible point for an isolator? So then I think again it comes down to we've got to consider, do we need that local means of isolation? If we believe due to the hazard and potential risk that we do, then we've got to consider it, and you can put them in the vicinity, but then it's a case of A, making the users of the installation aware of where they are, and B, if they're not visibly linked, so that it's not easily identifiable what that isolator is controlling or isolating, then it should be labelled accordingly. So quite often now, not just with kitchen islands, but also with people that don't want to see those multi-way grid switches above the work surfaces, quite often we're seeing isolators, cooker isolators, being put in in local kitchen units, which is acceptable, providing we meet all the other requirements, such as, you know, they're not going to be inadvertently operated, they are easily accessible to prevent or remove that danger. So yeah, good point about the kitchen islands. It doesn't stop the requirement, but it might give you some thought in terms of where you're actually going to locate them, because obviously there's no wall above the island, although sometimes they do have pillars or posts which go from floor to ceiling, which could be a convenient location for those isolators. Okay, so if we have a look at some of the other questions that have come in. So if my again, a common question to the technical helpline: if my circuit ZS is too high for a breaker, am I allowed to rely on an RCD to provide earth fault protection? So what's your thoughts on that one, Mark?
Yeah, you can. BS 7671 allows for overcurrent protective devices and RCDs to cover for fault protection, but you would need to also consider that the circuit still needs to be protected with short circuit and overload protection as well. Overload protection where applicable, but definitely short circuit protection. So, and if we're talking about a kitchen ring, then it will need to meet overload protection. But also, it's all well and good using the RCD, but you'll need to possibly investigate what is the cause of the fault in the first place. The high ZS, that could be reflected in the cross-section area of the cable or the circuit length, couldn't it? With older type circuits that are far too long, they'll often fail their maximum permitted ZS. So if the cross-section area isn't big enough,
Yeah, so it's always worth doing that sanity check to make sure that your measured ZS is reflective of the cable size and the circuit length. But if it is, and it does exceed the maximum ZS of your overcurrent protective device, then yes, 7671 allows us to use RCD protection, which is what we have to do when we're, for example, in a TT installation, and we can't, we generally can't meet the ZS of a breaker or a fuse. So yeah, it's perfectly acceptable to use the RCD, but as Mark said, that will only provide earth fault protection. We're still going to have another protective device, typically an overcurrent protective device, to provide short circuit and overload protection. Following on from that, we've been asked again something that comes up often as a result of domestic condition reporting. If due to the addition of thermal insulation to an upstairs ring circuit, I wish to downrate the circuit's overcurrent protective device, is it acceptable to use a 20 amp overcurrent protective device on the ring final circuit? So I think this one is referring to the situation where perhaps the original installation involved cables up in the attic area, and so we ran a normal ring final circuit with a 32 amp overcurrent protective device, and our 2.5mm cables that, when clipped direct, have got a nice adequate current carrying capacity of sort of 27 amps, I think it is. So that would be fine then for our ring circuit. But then at a later date, somebody comes along and installs a large amount of insulation material in their loft, and that sits directly on top of the 2.5mm ring conductors and greatly reduces its current carrying capacity. So the question is, can we downrate it to a 20 amp? What kind of things have we got to consider if we're going to downrate it, Mark?
I mean, first of all, you'd need to make sure that downrating it wouldn't cause any unwanted tripping, because that could become a bit of a nuisance if all of a sudden, you've cured one problem, but you've introduced another potential problem. It can, regulation 433.1.2, I think it is, gives that sort of deemed to comply status on a 32 amp circuit, doesn't it? And I think you can base there's a little formula that you can base your calculation on, which is the 20 amps times the 20 divided by 32, and that will give you a 12.5 amp equivalent under that regulation, that 433.1.2. So the simplest way to remember that, as I say, is 20 amps times 20 divided by 32. And you're looking at about 12.5 amps. So as long as your circuit that's been derated as a result of the thermal insulation, as long as your circuit, including that thermal insulation, can carry 12.5 amps, then yeah, absolutely you can. You just, if it's an upstairs ring circuit, then it's probably unlikely you're going to get some nuisance tripping. But if it's sort of one ring final circuit for the whole of the house, including the kitchen, and they've got lots of appliances, then you may well struggle to successfully do that. And you might have to think of some other alternatives, maybe like splitting the ring or something like that.
Yeah, so the 20 amp current carrying capacity is mentioned in that regulation, isn't it, where it talks about a standard ring either protected by a 30 or 32 amp device and wired in 2.5 mil line and neutral conductors. So yeah, it's basically a ratio, isn't it, that if we're going to downrate the cable because we've got that detrimental thermal insulation sitting on top of it, we still have to make sure that it meets current carrying capacity requirements. And so providing the cable will still carry 12.5 amps or more, then our overcurrent protective device of 20 amp would be suitable. But yeah, like you say, you've got to check against load, because we don't want that to create nuisance tripping if you have got a large load on that ring. Another one that's come in, again a common issue, perhaps in slightly older installations. So after replacing a domestic consumer unit, it's found that there's a shared neutral between the upstairs and downstairs lighting circuits. So it was quite common on the landing light situation. So is it compliant with 7671 to combine both lighting circuits to avoid the RCD tripping? Because that's normally where that situation manifests itself. We go from a board that's not RCD protected, all of a sudden we introduce two circuits that have got a shared neutral, and now we trip RCDs. So what's the guidance we hand out on that situation, Mark?
I mean, just initially, as long as that MCB can handle the load of both circuits, then that could be a good, albeit temporary, measure. But we'd recommend, where practicable, before replacing any consumer unit, that you carry out a condition report or some form of survey of that installation. Obviously, where the customer's prepared to pay for that, but that will identify any anomalies, any errors, any potential issues, exactly what we're discussing here, and then you can give the customer the advice accordingly. We do have a best practice guide number 1, which deals specifically with replacing a consumer unit, and in there it recognises the difference between a distress change or a planned change, and it will take you through a series of sort of verification tests by way of a kind of a risk assessment, there's that word there again, to let you make an informed decision as to whether it is actually going to be too risky, and whether the client needs to think about getting that repaired before you carry out any alterations or additions. So I mean, where it's not practical or the client doesn't want to pay, as long as you've done your necessary checks, as I said before, and the MCB can take the load and the characteristics of two circuits, then yes, you can do that.
Yeah, I think it's one of those ones that we obviously wouldn't do it if we were designing and installing the installation from the start. So again, it's something worth documenting. So on your consumer unit change, make it clear that those circuits existed already, and make it clear that the issue existed already. So what you've done has made it no less safe, and in fact improved it in terms of the combined circuits now have the enhanced protection of an RCD. But yeah, it's also we find a lot of people that steam into a consumer unit change on Monday, and then on Friday find that the RCD's tripping, and quite often a lot of those instances would make themselves known if you did some initial testing up front. Quite often insulation resistance testing, for example, would have found that, because you'd be able to see that you've now not got independent conductors across different circuits, so that would have shown itself, and then you'd have been able to have the conversation with the customer before, and perhaps talk about remedial work that would give them an enhanced system and still give them a better division of installation, while at the same time giving those new protective devices. So yeah, wherever possible, but we're fully aware that there's lots of emergency changes done, but wherever possible, try and do those fundamental tests up front before changing the consumer unit, so that you're not going to inherit a lot of issues which might cause you problems in the future. Okay, we'll take a look at some of the questions that are coming into the chat. So I think we talked about the isolator. Does local isolation require to be double pole? As an MCB in the regulations classified as an isolator, but in most cases not double pole. So in general, isolation in TN systems, so TNS, TNCS, doesn't require to be double pole, because it's seen that the neutral is referenced to earth within the distribution network, so it's not a concrete requirement. So in answer, isolation across the board doesn't have to be double pole, but it is specific. So for example, in TT installations where the neutral isn't referenced to earth and can float, then it's a requirement. But generally in TN systems, you don't necessarily have to isolate the neutral. You're quite right, there is a table, I believe it's 53.7, but it's certainly in that area of the regs, that tells you which devices have the capability to be used as an isolator. And so quite rightly, as you say, in some instances MCBs, which are only single pole, can be used as a means of isolation. Would you add anything to that, Mark, about isolators requiring to be double pole across the board?
I think unless it's a specialist installation that might require double pole isolation, and I can't think. I started to think there about operating theatres, things like that, but they'll have other systems in place to for that. But no, not off the top of my head. I was looking for the table that you mentioned that gave selection of protective isolation switching devices. Page 181, table 537.4. So that's page 181, 537.4. No, I think, as you say, other than a TT system and specialist installations that will require them, or ordinary systems on a TN earthing system wouldn't require it. Okay.
General question, when do you think the industry will wise up and move away from type AC RCDs? Also, do you see them becoming optional again? As I think we're all aware, at the moment type AC RCDs are still within 7671 for, I think it's general use. But we're as an industry, we're becoming more and more aware about the possibility of DC blinding, which is something that we used to use to our benefit in the past when we were doing things such as inspection and test and trying to measure loops. So we're aware of its impact, and certainly also aware of additional items which perhaps we've seen more and more being introduced, which can be a source for that DC current. So things such as PV inverters, DC charging for electric vehicles, and just general appliances, such as even things like mobile chargers. So yeah, it's something that I think we'll see over time transition. You know, I think it's one of those, it's almost akin to you know, when we first started to see RCDs being introduced as an enhanced measure to MCBs in the first place. So, you know, at the time it was a lot of instances, well, you know, MCBs are fine, why do we have to go? And then slowly it became more and more aware of the advantages of that enhanced protection provided by RCDs. The cost and them associated with them came down, so that it was actually then far more a level playing field. And so the enhanced protection was taken as becoming an additional protection requirement to in lots of instances where there's a greater perceived risk. I think it's going to be the same in that, you know, more and more we'll see type A's, and you know, we're seeing it already in things like special locations. So I'm thinking of vehicle charging in particular, where there's a greater perceived risk, where we're generally outside, so we're outside of an equipotential zone. We've got a large piece of conductive material that we can be generally in contact with while we're performing that charging role, and so there's an enhanced requirement, and also you've got the DC associated with the vehicle charging equipment. So we're already seeing it in instances where it's specified, you know, a type A or a type B or even a type F are all included in section 722. I would guess that over time we're going to see a more enhanced use, to the point where, you know, the associated cost comes down, and then people start to use those as de facto standard. We're certainly aware in some countries in Europe, you know, that transition is perhaps ahead of it as we are in this country, and they're seeing, you know, no more ACs and A's as a minimum. So yeah, I think it's going to happen over time. Not sure about optional. Again, we, you know, like most people, we're still waiting with bated breath to see which parts of Amendment 2 were the comments from the document for public comment, which ones were taken on board and are going to be published. You know, we've not got long to wait now. We're talking about April next year, so we're waiting with bated breath to see confirmation from the IET and the resulting JPEL groups, to see which things are going to be brought forward, which things are going to be maintained, which things are going to change. So like everybody else, we're waiting for confirmation of what's going to be in Amendment 2. Just jogging through, would you use a 25 amp MCB as an overprotective device? Perhaps need a bit more confirmation around that as to what question or which question that was related to. So perhaps if the engineer that put that in could perhaps give us a bit more information. Any plans for NIC Live next year? I think in general we're looking to see. We're obviously aware that there was an elect show recently, and we're trying to gain some feedback of attendance at that, to see if it's if it's a requirement and if it's viable. You know, we're still looking at, we've only just recently, for example, opened up our offices back for people to work back in the office at the start of this month. So yeah, just watch this space. We'll keep people certainly abreast and aware of what the plans are in terms of future events externally. In a consumer unit, can I use a 30 milliamp AC type? Again, perhaps a bit more information around the question. Certainly if it's 30 milliamp and you require the additional protection, then yeah, a 30 milliamp AC type or A type or B type, it's really the 30 milliamp rating, and then it's a determination of whether we have got any inherent DC circulating currents within the installation as to which type of RCD you'd use. If you have an RCD for additional protection, can you use the I2T value for the RCD instead of the overcurrent protective device for the discontinued CPC on an EICR when determining minimum CPC size? So let's just take that one again. Yeah. So if you have an RCD for additional protection, can you use the I2T value for the RCD instead of the overcurrent protective device for discontinued CPC on an EICR when determining minimum CPC size? So additional protection would tell me we're just looking at the 30 milliamp side of the RCD. And don't forget we're looking at, so if we're sizing the minimum size of the circuit protective conductor, we've got two ways. Either we do it by selection, so that's the crude method where we size it based on the size of the line conductor, or we use the adiabatic equation. I think what you're saying is then, can I use the disconnection time of the RCD for sizing the protective device under earth fault conditions? So
I think he might be saying, can he use that 30 milliamps in place of, can he use the 30 milliamp figure to calculate his CPC size? I think that's what he's saying, and that was, is that right? Because it depends. It depends on the, if I've got it, if I'm understanding it correctly, which I may not, it will depend on the level of fault current acting on that RCD. Because if you remember, Sam, it's either 10 times the short circuit rating of the RCD, or 500 amps, whichever is the, I think it's 500 amps, whichever is the biggest.
Okay.
So if your level of fault current is more than that, then it could potentially damage the RCD. Yeah,
that's the thing that I was going to talk about, is that we've got, the RCD's got a rating based on the fact that it's trying to disconnect when it sees an imbalance between line and neutral, which is very small. So yeah, depending upon your fault current, you could actually do damage to your protective device. I think that's where he's coming from. I think what we'll do is we'll take that one on board, and perhaps push something out through social media about the requirements, because it's a cracking question that I know was covered in the old days in our technical guide. So yeah, it's one of,
from the helpline.
Yeah. And so it's one of those ones in terms of possibly you can, but not under all circumstances. It does depend very much on your levels of fault current. But yeah, good question. We've got one, I just missed one above that. Amendment 1 compliant EV charger. How can we identify if those installed are 722.411.41 compliant on an EICR, for example, when connected to a TNCS system? So very difficult unless the person who did the install has helped you out by perhaps adding a statement of compliance. So for example, what we recommend to our registered contractors is that if they are using an OPEN device, which currently there is no British standard for, so that there's no British standard that they can reference, is to at least get a document from the manufacturer of the OPEN protective device, and attach that to their installation certificate, so that they've effectively got a confirmation of compliance with the protective requirements of that section 722.411, either it's ident 3 or ident 4 or possibly even ident 5. So get confirmation of that. Without that, it's very difficult. You know, there's no test equipment to test for it. The guidance is if there's no evidence of that, so it's not documented on the installation certificate, or perhaps you can't see the original installation certificate when the vehicle charging was recorded, then providing everything else is all right, it's recommended as a C3 in Best Practice Guide 4. So yeah, very difficult to confirm, because there's no test equipment, there's no British standard that things have to comply with. So it really is down to you know, you're a little bit down to the documentation that's provided by the person that installed it, as to give you a guide as to whether it is compliant with Amendment 1, or whether it only meets the previous 18th edition requirements. Would you add anything to that, Mark, on terms of when doing an EICR and we can't tell whether it's Amendment 1 compliant or not?
No, unless there's any previous documentation, you've got to sort of draw a line in the sand, haven't you? And as you say, you know, a statement from the manufacturer, if you know, in their instructions, they'll often say it complies with Amendment 1 ident 3 or Amendment 2 ident 3, but other than that, no, it's pretty difficult on a condition report. That's why we keep on advising about good record keeping and you know, moving forward, really. Okay,
we're running out of time rapidly, so we'll just have a look, see if we can answer any of the other ones that are in there. So the engineer that was talking about using a 30 milliamp type type AC RCD has said come back with in a split load consumer unit, can I use 30 milliamp type A RCDs along with type A 30 milliamp RCBOs? Well, you wouldn't generally use two 30 milliamp RCDs in series, because you'll have no selectivity between the two of those, and in general the one upstream is the one close to the supply is the one that's going to detect the imbalance and go first. So you wouldn't normally use 30 milliamp. You talk about a split load board, so if you've got a 30 milliamp RCD protecting one side, potentially without the other side, you could have RCBOs on all the other sides. The idea is that no, we shouldn't be mixing A's and AC's so that we've got an upstream issue. So for example, if you fit a type A because you're installing vehicle charging, for example, which requires you to at least fit a type A, then if you have got upstream of that of the EV charging equipment, you've got, for example, a standard type AC. The danger is that type A, although it's tolerant of the DC leakage, won't actually block it. So that DC could find its way back to any upstream AC devices and potentially blind them. So you've got to be careful about mixing. You should really, if you've got type A's or type B's looking after items of equipment or final circuits, then upstream of those devices on things like distribution circuits, you should also have either a type A if you've got A's downstream, or B if you've got B's downstream, or B if you've got A's downstream. So it has to be effectively either equally as tolerant to DC leakage current or more tolerant. You can't go the other way around and go a type B in a vehicle charging equipment and then put a type AC on the distribution circuit that's feeding it, because the danger is that type B will be able to tolerate the DC leakage current but won't act as a blocker, and that DC leakage could find its way back up into the installation and blind further RCDs that are on the supply side. Okay, I'm very conscious that we've got lots of questions still in there, but we're running slowly out of time. Where were we up to the questions? So, sorry, split row board. Is there a reg regarding hot zones for electric cookers? No, there's no specific regulation regarding hot zones for cookers, but there is a regulation or a set of regulations which talks about where we mix electrical installation, electrical wiring, electrical equipment with non-electrical, and ensuring that there's no detrimental effects either way, which we can either do by physical distancing or by thermal barriers. So I think it's around 528, section 528, Mark, something like that, that talks about where we've got electrical equipment in close proximity to non-electrical equipment.
Yeah, you're spot on, Sam. It's 528.1, page 148, top of page 148. Well, actually halfway down, because that's where we've got proximity of non-electrical services. Yeah, a wiring system should not be installed in the vicinity of services which produce heat, smoke or fumes likely to be detrimental to the wiring, unless it's protected from harmful effects.
Yeah. Another one that's coming. So best practice guide 4 states a borrowed neutral is a C2. So how can you accept a board change with a borrowed neutral? Okay, good point, but perhaps what we missed to point out is that when we do the board change, we're actually combining those two circuits into one. So now we don't have a borrowed neutral anymore. We do have a less or not as good division of the installation, which has to be considered. So we have to make sure that that doesn't introduce any hazards. But in terms of we're actually combining the two circuits, so now we have a common neutral for one circuit rather than a common neutral for two. So that's why we can do it without keeping the C2, which we would recommend as a classification code for a borrowed neutral. So perhaps make that clear that it's that's how we get around it, by combining the two circuits, which of course, as we said, does have that detrimental effect in terms of division of installation. Okay, another one under BS 5266, emergency lighting should be tested for the duration of the design of the fitting, i.e. 3 hours annually. Can this be reduced to an hour at customer request, as I don't think it would meet the requirements? It depends on effectively the risk and emergency evacuation associated with the building and the installation use. So you can get 1 hour evacuations. So again, that would be back to the fundamental in terms of the risk assessment, which should result in what level of duration is required, and it's normally associated with the evacuation and also the processes that are taking part in the installation. Because, for example, you might have a chemical process that has to complete its cycle, because otherwise it results in dangerous or explosive equipment. So it's not just the evacuation, but also the processes involved within the site that will determine the required duration of your emergency lighting. So it could possibly be an hour.
It also depends on the batteries that are installed and the design of the installation in the first place, because you can get 1 hour batteries. I mean, but all of those factors that we've discussed, really. Yeah,
but so to that engineer, I would suggest go back to the client and ask to see the risk assessment process that resulted in the emergency lighting design, because that will then help. Now, Murphy's Law says that won't be available because it was done X many years ago, in which case you might then have to repeat that process in order to determine what duration is required for that actual site. Okay, old fuse panels in an industrial installation where 3-phase machines are used and there is no main switch to the panels, are they worthy of coding on an EICR? So I guess if we're talking about old fuse panels in an industrial installation where three-phase machines are used and there is no main switch to the panel. So if we've got no means of isolation, typically the users of the installation wouldn't tend to be involved in isolating unless we've got that situation where there's a risk of danger to the user. So we've got heat generating or mobile parts. So I think you've got to first of all do that risk assessment as to do I need a means of local isolation to prevent danger. So think about the dangers associated with the equipment that's being supplied. And then that will determine whether you need it or not. If you need it, then you would consider recording it on an EICR, depending upon the hazards and risks associated with it. So it could possibly be a C2 or a C3, depending upon the hazards and risks associated with the equipment. But yeah, it would really need to be determined, because in general, it's not a requirement, because in instances, you may be able to get a competent person to remove fuses, but again that requires PPE, etc. So again, think about the actual installation, because it's possibly dangerous if I can't isolate equipment that's got a high risk and a high hazard for the users of that installation.
I mean, it might be about emergency stopping. I mean, if you're talking industrial, isolation would be the sort of secondary consideration, and then emergency stopping, it could be all about that. You need something local if you've got woodworking machinery or large equipment, big metal cutters, things like that, fabrication workshops. So don't get hung up just on isolation, because you've got emergency stopping there, you've got switching off the mechanical maintenance. They're all linked, they're all in that same section, but it does boil down to that assessment, as we keep going back to, and the types of equipment and who's using it and all the rest of it. Okay.
We're going to have to call it a halt there, because we're way over. I do thank you very much for the participation in the questions. I do apologise if we didn't get round to your question, but we will use those as our starting points for next time. Just before we disappear, I just want to tell you what else we're doing in the near future. So we have got some wire webinars coming up. So these are on the Wednesday nights of the weeks when we don't do the Q&A sessions. So next one is next week. That's the second part of a presentation on protection against fire in 7671. 2 weeks after that, so in the early part of November, we've got a presentation about the new electrotechnical assessment specification. It's not actually new, it was actually published in 2020, but there were some major changes came into effect in 2021, so that's of interest. And then towards the middle to end of November, we do have another coding clinic. That's Coding Clinic 10 in this episode. So those are all available to register for on the website. You can go onto the NICIC.com website and register for those. And the difference is you do need to pre-register to watch those live, and also you can pre-register. You can also enrol to watch them back. We've got something like a year's worth of wire webinars, which you can look on the on-demand side of the website, so you'll be able to view those. So once again, thanks very much for everybody's participation. Some great questions that have come in this week. It's really good to see, and like I say, we will take the ones that we haven't been able to get round to this evening and answer those separately. So do please come in. All I would say is get them in early, and by all means post them onto our social media channels, and we'll try and do them in the weeks when we're not doing a Q&A session as well. So we tend to find that we do get some quite good hits on the questions that we post out in the week. So thanks very much. You want to add anything to that, Mark? Again, another one of those, it's always the quickest half an hour which turns into 45 minutes of my life. These things, it's always interesting.
It is, yeah. I mean, you know, you often think, well, you know, it'd be nice to have a bit longer, but I'm sure some people will like that and some people wouldn't like that. But no, great questions this evening, Sam, and yeah, thanks for everybody participating, and I'll see you again soon.
Yep, that's great. Well, thanks very much, and please stay safe and well in these crazy times. Get your registrations in for the wire, and we'll see you again.